extract the attendance tracker first. Okay. Thank you. Okay, so good afternoon, everyone. So I think you can now see my screen. And our next topic will be about fuels and combustion. Okay. Okay, so fuel is any substance, natural or artificial, which upon combustion releases heat energy. No? So fuels, when heated, undergo a chemical reaction with an oxidizer, which typically is oxygen in the air, para mo liberate ang heat, di ba? So combustion is synonymous to oxidation and is the union of oxygen with combustible materials. Okay, so during the process of combustion, so we have the hydrogen and carbon, combined with other combustible materials. For the classification of fuels, we have solid, liquid, and gaseous. So solid, mo is like example, coal, coke, wood, charcoal, bagasse, coconut shells, rice husk, and briquetted fuels, or simply known as mga biomass, no? We have fossil fuels as solid fuel, but those are non-renewable. And kita in the engineering, we are encouraged to use biomass for for fuel. We also have liquid fuels such as crude, petroleum, and its distillates such as gasoline, alcohol, kerosene, diesel, bunker, and other fuel oils. For gaseous, we have natural gas, artificial gas, blast furnace gas, and LPG. Now we also have methane from mga landfill. We have acetylene, and then propane. So these three, the solid, liquid, and gaseous, are what we call the primary or the natural fuels. Then let's talk about the properties of fuels. So first, just like when we tackle about fluids, so importante kaayo ning learning the properties of kung unsa man na siya nga let's say fuels or fluid. So the first properties of fuel is the analysis of composition. So kani siyang analysis of composition, mura mo ni siya mo assess sa quality sa coal or sa fuel. Okay? So we have proximate and ultimate analysis. So I think na master na ginin ninyo, kay I believe si Sir Manilihig ang inyong combustion in your third year. So I know how he kanang covers his mga lesson, very detailed. Okay, so for proximate analysis, it is an analysis of the composition of fuel, which gives on mass basis the relative amounts of moisture content, volatile matter, fixed carbon, and ash. Okay? So, on mass basis, so kani siya nga mga relative amounts kay mga weight percentage ni siya, no, present in coal. Okay, so pila iyang moisture content in percentage in the volatile matter, the fixed carbon, and ash, no. So let's say sa coal, no, unsay iyang mga relative amounts ani niya nga mga element or content, no, ana nga coal. For the ultimate analysis, the same weight percentage gihapon ni siya. Pero it is the relative amounts of carbon, hydrogen, oxygen, nitrogen, sulfur ash, and moisture. No, that is for the ultimate analysis. For sa mga problem, i-specify mo na siya, no, kung with a given ultimate analysis, then ihatag niya ning mga relative amounts or weight percentage ani nga mga element. Okay. Next we have, so if we total, no, kani sila, for example for proximate, if we total moisture, volatile matter, fixed carbon, and ash, so ideally it should equal to 100%. No, same with the ultimate analysis, kaning carbon, hydrogen, no, so dapat mo equal po ni siya ito 100%. Pero naay mga ultimate or naay mga composition nga dili siya 100%. No, naay analysis ng iyahang sulfur, for example, kay wala ba, zero siya. No? So in that case, dili na 100% ang ultimate analysis ana nga fuel. Okay. Next property is we have the specific gravity. So for fluid, that is density of fluid divided by the density of water. For gas, that is the density of gas divided by the density of air. Next is we have degrees API and Baume gravity units. So kani siyang degrees API o Baume, mo ni siya ang ginagamit to indicate the quality sa crude oil. No, specific ni siya for crude oil. Mura ba og ihang i-determine how light or heavy crude oil is, no, by finding its degrees API and degrees Baume. Okay, so for water with an SG of 1, ang iyahang API or degrees API is 10, no, for kuan na siya for water, no. So kani siyang degrees API again and Baume mo identify ni siya kung mura ba og how light or heavy crude oil is compared to water, no, compared to water. Okay, so the formula for degrees API, we have 141.5 divided by SG at 15.6 minus 131.5. Ang difference lang nila sa Baume is 140 and 130. Okay. Next is the specific gravity at temperature or at certain temperature. No. So like for example, if we're getting the degrees API or degrees Baume, so kinahanglan mag SG, no, at 15.6. Then sa problem, the SG at 15.6 is not given. You still have to find. Then kani nga formula ang ato ang gamiton, no, where SG is the unknown. SG at 15.6 is the unknown. Okay, so the specific gravity at temperature T or certain temperature that is equal to SG at 15.6 divided by the correction factor. And correction factor is equal to this 1 minus 1 or 0.00072 times the given temperature minus 15.6. Okay, that is in degrees Celsius. Then another value for degrees Fahrenheit. Okay. Okay. So mo na itong gamiton, no, nga formula if the SG at 15.6 is not given in the problem. Next, we have heating value or the calorific value. No? Unsa gani ning heating value? Di ba mo ni siya the most important characteristic or property sa fuel, di ba? So, unsa gani ni siyang heating value, Mr. Aheno? Na si Jermaine? Kay di ba yung naanin man to inyong or si Felicita? Di ba mauman ni inyong sa sis? Unsa gani ng
Kuan ma'am, amount of heat nga amount of heat energy nga i-release sa fuel.
oh yes, i-release a fuel when it is completely burnt, di ba? Kung completely burnt na, yes, sakto to know, it's the total heat generated when a unit of fuel is completely burnt. So maunang iyahang unit is kilojoule per kilogram, or the heat released per unit mass, di ba? So for higher heating value or gross calorific value, it is the heating value obtained when the water in the products of combustion is in the liquid state, meaning condensed, no? So more ni difference nila between higher and lower heating value. So kaning lower heating value when the water in the products of combustion is in the vapor state. So that means na water vapor remains in gaseous state, no? Pero murag ang difference lang aning iyahang higher heating value o lower pod is that kaning higher murag mao ni siya total heat generated, no? When a unit of fuel is completely burnt, while kani siyang lower is murag net heat, no? Net heat produced when a unit of fuel is completely burnt. Okay. So in getting the higher heating value of solid fuels, no, like we have the biomass, fossil fuel. So we can use first the Dolong's formula. So we can use the Dolong's formula if, no, notice niyo ang C, H, O, and S. So we can use this Dolong's formula if the ultimate analysis is given in the problem, no, such as the weight percentage of these elements for the carbon, hydrogen, oxygen, and sulfur. Okay, makagamit sa Dolong's formula. For petroleum products, no, that is for the gaseous fuels, we can use this ASME formula. So na siya 41,130 plus 139.6 times the degrees API, di ba? So ang degrees API kanina again is used to in or murag indicator ni siya or sa quality sa crude oil. So crude oil is under excuse me, kanang liquid fuel. Sorry, dili dito gaseous liquid fuel, no? So mao nang iyahang formula as may formula is 9 degrees API. Kay degrees API again is for crude oil or mga liquid fuels. Okay, but naglibog po ko nga nung under siya sa higher heating values of solid fuels. But anyway, so naka-specify man po siya diri, no, as may formula for petroleum products. Then for Bureau of Standards formula, so kung SG lang ang given sa problem, then we can use this one. Okay, so SG squared. For the lower heating value of solid fuels, that is equal to the higher heating value, excuse me, higher heating value minus 9 times H2. H2 is, this is how to get the H2, times the 2442. Okay, so 2442 is not constant, no? I mean, 2442 can only be used if your QH is in kilojoule per kilogram. So you have to be careful, ani niya, no? Para consistent ang inyong unit. Otherwise, no, dili na nito for 2. Kung dili in kilojoule per kilogram inyong QH. Mo na nga na I note of conversion dere where 1 BTU per pound is equal to 2.236 kilojoule per kilogram. No, in case ang sa problem is BTU per pound bitaw, no, in English siya. So kinahanglan nga i-convert pa po ninyo siya to this one, no. Pwede pod nga saan mo na siya. Pwede pod balihon, no. Ang 2442 ang inyong kuhaon kung pila yung ma-value ana para magamit ninyo ang BTU per pound. Okay, so H2 is equal to 26 minus 15 times the SG. Okay. So those are the important properties of fuels. Next, we'll have combustion of solid fuels. Okay, so we have this what we call theoretical weight of air. So, Mr. Felicita or Mr. Aheno, nag-compute ba mo sa inyong weight of air dito sa inyong thesis? So anyway, so theoretical weight of air is marang na siya og minimum, no? Minimum amount of air needed for complete combustion. Okay. Again, theoretical weight of air is the minimum amount of air needed for complete combustion of air. So muna ang iyahang formula, unit is kilogram air per kilogram of fuel. No, because we also have actual weight of air. So theoretical weight of air, also known as air-fuel ratio. No, kay naani siya murag mga mga similar terms ani niya ba nga i-mention sa problem. Usahay na problem nga moingon og find the minimum amount of air or find the theoretical air-fuel ratio. No? So digi siya moingon ba nga find the theoretical weight of air. So it's important that we unsay mga learns the different mga terms ana niya. Okay? So theoretical weight of air is the exact, no, or what we call ideal the amount of air as determined from the combustion reaction of air needed to burn a unit amount of air, unit amount of fuel. So if the ultimate analysis of the coal is available, which is katong mga weight percentage sa carbon, hydrogen, oxygen, sulfur, and moisture, no, then the theoretical weight of air required to completely oxidize, no, the fuel can be calculated with this formula. Okay, so air-fuel ratio or theoretical air-fuel ratio or WTA is equal to 11.5 C or the carbon content of the fuel plus 34.5 times H or hydrogen minus oxygen divided by 8 plus 4.3 times the sulfur content. Okay, so kay air fuel ratio man, so that is in kilogram air per kilogram of fuel. Okay, so so theoretical weight of air is the ideal proportion of air to completely burn the fuel. Okay. So ang gimin po niya sa proportion diri is murag pila lay minimum of air needed, no, pila lay sakto nga air needed for complete combustion sa fuel. If the ultimate analysis of coal is not available, then an approximate formula to obtain the theoretical air-fuel ratio when the heating value of the fuel is known. So kung wala ultimate analysis but the QH is given or QH can be directly solved, then mao po niya ang formula for the theoretical air-fuel ratio. That is in QH divided by 3117. Okay? So that is in kilojoule per kilogram. No? So careful mo ani nga mga constant, no, or value kay depende ni siya sa unit. Okay? So for QH in kilocalorie per kilogram, that is divided by 4. Then for QH in BTU per pound, that is divided by 1340. So this is the formula if the ultimate analysis is not given. Next, we have actual weight of air. So mingon taog actual weight of air. It is the weight of air supplied for combustion, or the weight of air supplied for combustion is necessarily in excess of what is theoretically required, no, more than what is the minimum or more than what is the ideal. Okay, mo na siya actual weight of air. So the volumetric analysis of the dry flue gas can be used to calculate the actual weight of air. This is what we call the volumetric analysis. No, kaning naa na ang carbon dioxide, carbon monoxide, nitrogen, no? So, pero usually sa mga nasugatan, seldom lang naning given ang volumetric analysis niya. But if ever na makasugatan nga problem, the formula is 1 divided by 32.72 times the volumetric analysis. Okay. If not given, then we can use the percent excess air. No, so that is theoretical weight of air, no, or the theoretical or the minimum amount of air times 1 plus percent excess air divided by 100, where the percent excess air, no, percent excess air is equal, no, to theoretical actual air fuel ratio minus the theoretical divided by the theoretical air fuel ratio, okay, times 100. Okay, percent. So that is the formula for the excess percent air. So usually, no, kani siyang magamit nato. So if dili given an excess air, then we have the formula for the percent excess air. No, so we have to find the the theoretical air fuel ratio and the actual air fuel ratio. Okay, so WAA stands for the actual weight of air, including the excess air. Excess air, di ba we have the kanang ganing. We have fuel. Fuel. Di ba naman tayo fuel plus air equals to, sama ni? Equals to, fuel plus air is product of combustion, no? So kana siyang giingon nga percent excess air is nana siya diri dapit, nana siya diri sa air. Excuse me. Okay, where C is the weight of carbon per kilogram of fuel from the ultimate analysis. Then the N2, CO2, and CO are the percentages by volume. So mo itong gingon ako diri nga this is a volumetric analysis no of the component gases in the flue gas as obtained by RSAT analysis. Okay, next is we have analysis of flue gas. So what is flue gas? Mr. Beru. Sama ng flue gas. Hello, madungog ba ko? Hello, madungog ako?
Yes, ma'am.
Ay, okay. Okay, basit o. Nawala na, nahang na. So, unsa man naman ng tao flue gas?
Para na po, ma'am. Exhaust gas, gikan sa combustion.
Yes, no. So, muna sila yung mga gawas, no? Mga mixture of gases na sila nga gawas sa combustion chamber. No? So, gaseous products, or kana siya, no? Mixture of gases of combustion are analyzed using gas analyzer known as the RSAT apparatus. So, the combustion products contains carbon dioxide, sulfur dioxide, nitrogen, oxygen, carbon monoxide, and water vapor. So the result of the analysis of dry flue gas by volume can be expressed by this equation. No? So CO2 plus CO plus O2 plus N2 is equal to 100%. So this is for flue gas. Okay. Then we have the weight of gaseous products liberated during the combustion of fuel with air. So we have this formula. So actual weight of air plus the weight of the flue gas. No? So that is in kilogram per hour. Then the weight of dry flue gas formed per kilogram of fuel burned is given by this formula. Okay, so we have actual weight of air plus 1 minus the SO2 plus H2O plus ash loss. And to get this SO2 and H2O, mao sad ni ang iyahang formula. Okay, so makuha gihapon nato ni siya sa ultimate analysis. No? Mga weight percentage ani niya nga mga content or element. Okay, so here's the formula no for the excess air. So actual air fuel ratio minus theoretical air fuel ratio divided by the theoretical air fuel ratio. Okay, so next we have combustion of hydrocarbon fuels. Okay, so hydrocarbon fuels consist mainly of combustible elements carbon and hydrogen. Diba? So mainly kaning hydrocarbon fuels are fuels made only of carbon and hydrogen atoms, no? So when they burn in oxygen, no, kaning carbon and hydrogen, when they burn in oxygen, mo nang mag-produce siya og kanang CO2, carbon dioxide, then H2O, mao na nga kani siya no nga formula So fuel plus air equals the products of combustion. Because for hydrocarbon, when these when these elements, carbon and hydrogen, are burned, when carbon and hydrogen are burned in oxygen, no, mao nang ma-produce siya og product of combustion, which is the CO2H2O. Wait lang, karayo lang ha. Wait lang ha. Okay, so sorry sa interruption na lang ko gitubag nga important call. So, balik ko no. This is the typical combustion reaction of fuel with known chemical formula. So mo to kong giingon nga for hydrocarbon fuels, no, when they burn in oxygen, mo na mo produce sila og kaning CO2 and H2O. Okay, so mo ning usa sa mga products of combustion. So we have fuel plus air equals to products of combustion. So for the fuel, no, given by CnHm, where M and N depends on the hydrocarbon family, or kaning number of, it represents the number of atoms, no, plus air, which is consists of the oxygen and nitrogen, no, so naapod siya corresponding nga number of moles, then the product of combustion, no, the CO2, H2O, and then the nitrogen. Okay, so A, B, and C represents the number of moles ni sila. Okay, for the composition of air by weight, no, oxygen is 23% and nitrogen is 77%. Kung by volume, no, this is 21% for oxygen and 79% for nitrogen. So the molal ratio, kani siyang 3.76, no, mo ni siya ang molal ratio. This is obtained by volume of nitrogen to oxygen in air when both gases are at the same temperature. This is how 3.76 nakuha. Okay. Next, we have combustion, or example naman din, no? So let's have an example, combustion of hydrocarbon fuels with theoretical air, no? Hydrocarbon fuels. So, liquid octane given by C8H18 fuel is burned with ideal proportion of air. Calculate the ideal air-fuel ratio by weight. No? So we have the formula for air-fuel ratio, or this is ideal or theoretical, di ba? So, kaning air, so mo ni ang mga sa may air na to, the oxygen and nitrogen, no? Divided by the fuel, so we have the carbon and the hydrogen. Okay, so air fuel ratio kaning formula dere, no, for kuan man ni siya solid fuels, no, so don't kanang be confused, no, with this formula, no, for the theoretical and actual weight of air, because this is for the solid fuels. For this one, this is for the hydrocarbon fuels. Okay, so ano lang na siya, literal nga air fuel ratio. Okay, so natay kaning say tawag aning combustion reaction nga equation. So kani siya nga equation represents the complete combustion of a hydrogen fuel in air, no, air na yan gikuan. So first thing to do is to balance this equation, no, kay unknown pa man yung A, B, and C, which are the number of moles, diba? Oh, moles, number of atoms rather. Okay, ay, number of moles lagi, no, kay atoms is maumanday ng iyahang subscript. Sorry. So ano man ang A, B, and C? So mo nang kinahanglan siya pangitaon. So we can come up with the balance equation. And to find that, no, in balancing the material, let's start with the carbon. So 1 times 8, because 1 that is the number of moles, no? So both for carbon and hydrogen, ang iyahang number of moles is 1. Okay, wala ramay nakabutang. So that is 1 times 8, which is the number of atoms. Okay, equals to, so nga na pa na siya, no? Equals to the product of combustion or corresponding product of combustion, which is B times number of atoms for carbon in the product side is 1. Okay, so B times 1. Okay, so P is equal to 8 kilogram mole. So 8 divided by 1. Then for hydrogen, so 1 as the number of moles, 18 as the number of atoms, no? Equals to the product of combustion, that is equal to C times the number of hydrogen atoms, which is 2. So 18 divided by 2 is 9 kilogram mole. For oxygen, no, A times 2 for the number of oxygen atoms equals to, sama na siya, anay oxygen dire, no, sa first product, and also this one. Okay, so that is equal to B times the oxygen atom plus C, yung nga oxygen atom po niya dire nga 1. So that will give us A equals to 12.5. Then for N, so that is 3.76 times A na 12.5. So that is 12.5 times 3.76. So that is 47. Okay. This is for the nitrogen, no? The number of moles for nitrogen. So we now have a balanced equation. So therefore, the ideal air fuel ratio by weight, no, this is by weight, that is 12.5. So diba, this is for oxygen. Kay air man, we have oxygen and nitrogen. Then 12.5 times 32. 32 is from, so many. 32 is from molecular weight of oxygen, na 16 times the number of atoms, na 2, manang 32. Then we have 47 for the nitrogen times 28. 28 also comes from molecular weight of 14 times 2 na number of atoms. Divided by the fuel, so we have carbon. Carbon nga, anong 96 man eh. For carbon, we have 8 times 12, because carbon has molecular weight of 12. Sakto ba? 8 times 12. Oh, tama no? So 96 comes from, we have 8, no? This is kay fuel mani. So this is, tanga natin ay carbon and hydrogen, no? So 96 is from 8 times the molecular weight of carbon, which is 12. Okay. So 1 lang ni. Okay, manang 1. Then, nasa gikan ng 4. 18 is from, so many hydrogen, no? So 18 is from hydrogen, molecular weight is only 1 raman. So that's 18. So dapat wala na ning 4, no? I think, mga paghihapon na ihang correct answer. So typo error lang ning 4. Okay, so mo ng 15.05 kilogram of air divided by kilograms of fuel. Okay. So na may question? Na may question aning example? Wala ra. Okay. Let's have combustion. Another example. Sa combustion of hydrocarbon fuels with excess air. Okay. So a typical industrial fuel oil, C16H32, is burned with 20% excess air. Calculate the actual air-fuel ratio by weight. Okay, so naman siya percent excess air. So we're finding the actual air-fuel ratio. Okay, so the same process, no? We have this theoretical reaction equation. Then we balance it out. No, so makuha itong value for A, B, and C. So this is now the balanced equation. But na may given nga 20% excess air. No? So you have to get the actual reaction equation. So from this one, no, na naman siya 20% excess air. No? So sa excess, sa air man na siya. So as we know, this is fuel, the C16H32, and this is the air. Diba? Mauna, nga naa diri ang atong 1.20. Okay? So 20 is the 20% excess air. No, excess man, meaning sobra. No, so dapat 1.20 na siya, dili siya 0.20. No? And then we also have air ari nga side sa product, nitrogen. So mo nang multiplied also by 1.20. Okay? Representing the percent excess air. Okay? So naa siya diri pod sa products of combustion, again kay naa may nitrogen. Okay? Then from that, balance na pod, no? Then you will get the D, then this is the final balanced actual reaction equation. Okay, so same, try ninyo ni og balance. Same procedure lang. There is a first example. Okay, then the actual air-fuel ratio by weight is equal to, so this is for oxygen, we have 28.8 times 32 plus the nitrogen nga 108.28 times 28 divided by the fuel. So we have my fuel na to, the carbon and hydrogen. No? So we have 16 times 12. No? The number of atoms times the molecular weight plus hydrogen. We all, molecular weight of hydrogen is only 1 divided by the 32 nga number of atoms. So mo na makakuha taog 17.65 kilogram air per kilogram fuel. Okay? Ano may question? Na may question? Wala ra? Okay. So let's have an example. So natay example dire. Wala man ni siya matiwas ko dog solve kanina. So let me erase. Mani ano kaya mani ma-erase. Tsambahan. Okay, so we have this example. A certain coal has the following ultimate analysis. So we have values or weight percentage for carbon, sulfur, hydrogen, oxygen, nitrogen, ash, and moisture. So, so kung i-total nato ni siyang ultimate analysis, this is equal to 100%. So a Stoker-fired boiler of 175,000 kilogram per hour, steaming capacity, uses this coal as fuel. So we have this given, no, 175,000 kilogram per hour. So this is the amount of steam produced per kilogram or per hour, per hour of by the boiler. Okay, steaming capacity man siya. So muna siya mas flow rate, no? Calculate the volume of air in cubic meter per hour with air at 15.6 degrees Celsius and 101.325 kilopascal. The coal is burned with 30% excess air. We have boiler efficiency of 70% and factor of evaporation of 1.1. Okay. So, sa may formula gamito nato. So we are finding the comment. So we have to find the volume of air. Okay, so this is the volume of air required for combustion sa coal. Diba? Kaya mo siya calculate the volume of air, the coal is burned with when the coal siguro ni kuwang na yun, when the coal is burned with 30% excess air for combustion of coal. Ay. Okay, so find the volume of air required for combustion of coal. So what formula can we use to get this formula? To get this volume of air. Sa formula, magamit na to ani. So naman tayo given, no? Nga, ingon man diri, volume of air at 15.6 and 101.35 kilopascal pasabot na atay temperature sa air and pressure sa air, no? Kaning 15.6 and 101.325. Kaya ingon mo siya calculate the volume of air at with air at, no? So naatay temperature and pressure. So we can use the PVMRT. Please forgive my writing kay maglisod yung kanihang pen. Then PVMRT, so that is pressure sa air, then mass sa air and temperature sa air. So volume sa air is mass sa air, the R or gas constants times the temperature of air divided by the pressure of air, PVMRT. No, kani. Then for we have R, we also have temperature sa air and then pressure sa air. Okay, so we have to find the mass of air. Okay, so how will we get the mass of air? Unsaon na to pagkuha ang mass sa air ani ron? So solving for mass of air. Okay, solving for mass of air. Unsaon man nato ni ron? So mass, unsa may unit sa mass of air. So that is kilogram, maybe kilogram of air per unit hour. No. So mass, sumingon tawag MA, mao ni siya amount of air required for the combustion of fuel. Okay, so this is the amount of air required for the combustion of fuel. So that means, so kung kilogram of air per hour na siya, mass of air is equal to mass of fuel times the air fuel ratio, no? Theoretical fuel ratio. So mass of air is equal to the total air required per kilogram of coal times the mass of coal burned per hour. Ni siya. So kung ato siyang mass of fuel, that is in kilogram, or air fuel ratio, kilogram of air divided by kilogram of fuel. Kilogram of air divided by air. Kilogram of fuel. No, so mahimilin kilogram per hour. Okay, so sakto no? So ako lang i-verify ang ato ang formula in getting the mass of air. Okay? Now, saan man nato pagkuha? So pwede rin nato makuha dito ang air fuel ratio. No, solving for the air fuel ratio. So we can use the DeLong's formula kay naa may ultimate analysis. So we have kanino? Okay, so we have 11.5 C. So ato na yung i-show. Carbon content is 70.5, 0.705 plus 34.5 times hydrogen nga 4.5 0.045 minus oxygen nga 6 divided by plus 4.3 times S nga 3.0, so 0.03. So this is equal to, so that should equal to 9.53. kilogram of air divided by kilogram of fuel. Okay, so naana tayo air fuel ratio. Okay, now we have to find for the mass of coal, no, mass of coal, kaning MF, mass of coal burned per hour to produce the amount of steam, no, 175,000 kilogram per hour. Okay, again, kani siyang MF is the mass of coal burned per hour para ma-produce ni siyang 175,000 kilogram per hour nga steam, no? So how are we going to solve that? Okay, so na may given, no? Kaning ubang given, mao man gani ato ang mga clue. So you have boiler efficiency and factor of evaporation. So if you can recall, we have the formula for factor of evaporization from factor of evaporization if you can recall, that is HF minus HS minus HF. So HS minus HF is mauna siya ang latent heat vaporization, no? Please correct me if mali akong pagkadumdum, no? But HS minus HF is what we call the murag latent heat of vaporization, no? So murag heat content. So yung latent heat, amount of heat required to convert 1 kilogram of water into steam, no? So ayan na to if sakto ning iyahang unit. Divided by the 2257. If you can recall this in your thermo 2, okay. So kung kilojoule per kilogram, then kilojoule per kilogram. Okay. So, pero murag okay, sakto no. Then HS minus HF divided by 257. No, dili ni siya latent heat. Sorry. Wrong tong ganina. Dili ni siya ano. Or the actual. Anyway, bisan mao ni iyang formula, no? For the factor evaporization. So from that formula, we can get the HS minus HF. So that is FE, which is 0. Factor evaporation is 1.1. 1.1 times 2257. Kani siyang 2257. Marag mo ni siya theoretical, no? Nga para sa water at 100 degrees Celsius. Murag mo niyang latent heat. So murag sakto da itong HS minus HF nga latent heat of vaporization. Yeah, murag sakto da ito. So this is kilojoule per kilogram. Okay, so this should give us 2482.7 kilojoule per kilogram. Okay, HS minus HF. Then kana siya, magamit nato na siya in getting the mass of fuel. Okay, so mo gana itong ginatry ko ang mass of fuel. Then after that, from boiler efficiency. No? Excuse me. We have output, no? Mass sa steam times the HF, HS minus HF divided by input nga MFQH. Diba? Ma-recall ninyo ni. So, therefore, mass of fuel is equal to mass sa steam. We have mass sa steam of 175,000. 175,000 times the 2482 ito na kilogram per hour times 2482 kilojoule per kilogram. Divided by the MFQH. So we have QH. Ay, wala na tayo QH, no? So ito sa tao ng solving for QH here. So for QH, we can use the DeLong's formula, no? QH. DeLong's formula kay given man ang volumetric, ang ultimate analysis. So to get that, so 33 times the carbon content of wala tayo carbon content niya. Carbon 70.5 times 0.705 plus 144,212. Hydrogen is 0.045 minus 0.6%, 0.06 divided by 8 plus 9304 times sulfur content na 3%, 0.03. Okay, so this should give us 29,530.17 kilojoule per kilogram. Okay, so diri na siya 29,530.17 kilojoule per kilogram. Okay, so the mass of fuel is equal to, so this should give us 21,018.33 kilogram. So this is kilogram of coal, no? Kay mass of fuel man siya, kilogram of coal per hour. Okay, so that is the M. Therefore, sumpay na ko diri, no? plus mass of air, a volume of air. We're looking for the volume of air is equal to mass of air nga, ano, di pa di ay, mass of fuel, pamanday ni na. So, therefore, mass of air is equal to mass of fuel, 21,018.33 times the air fuel ratio nga, air fuel ratio, 9.53. Air fuel. Air di ay ni, sorry. Kilogram air fuel. Okay, so this should give us itry ko na ninyo pila man 21,018.33 times 9.53. Times, kuan pa rin siya, no? Naman siya percent excess air. So that is times 1.3 pa rin siya. .3 nga excess air. Okay, so this is excess air. So this should give us 260,396 kilogram of air per hour. Okay, so this is the total amount of air required, no, for the combustion. Okay, then mass of air is 260. MR, we have 0.287. Then temperature of 15.6 plus 273 divided by PV. Pressure nga 101.325. So the answer should be equal to 212,861 cubic meter per kilogram. Sorry, per hour. Okay, so mo na yung ato ang volume of air. Okay, so now my question sa itong example. Hello? So basically, no, ang atong gigamit is the PVMRT. So we find or we solved for the mass of air, no, needed for or required for the combustion. Okay, so here we get the air fuel ratio by or the theoretical air fuel ratio. Then kani siya nga mga formula, factor of evaporization and the boiler efficiency, which is output over input, no? So kani siya magamit raman ni siya nato sa steam power plant, kani nga formula, no? Also the factor evaporization. Okay, so we use the boiler's efficiency formula to get the mass of fuel or mass of coal burned per hour to produce the 175,000 kilogram per hour steam. Okay. Then we have, we get the QH, and so nakuha na to po ang mass of air. Okay, so na may question? Okay, kung matanaw mo gud ta sa reviewer, ang reviewer is kanang kinahanglan mitag jud pud siya og i-review pud og taman kay og nasipya ta sa mga formulas na usahay kay dili na siya mag-formula dito na og substitute, no, sa mga values. So at least kay bauta kung asa gikan, no, sa mga formula ang gigamit. Okay? So any questions?
Excuse me, ma'am. Constant na ba daw ng 257?
Constant meaning 2257. Yes. Kani siyang 2257. Murag mao ni siya theoretical for water at 100 degrees Celsius na latent heat. No, kaning 2257. Kuan siya, constant ni siya kung ang imong HS minus HF is in kilojoule per kilogram. Otherwise, dili na ni siya 2257. Okay, this 2257 is in kilojoule per kilogram. Okay, mura ni siya katong mga formula ganiha nga lahi-lahi og value kung ang QH is lahi-lahi pod og a unit, no? So this 2257, yes, it's constant for kilojoule per kilogram, no, na HS minus HF. Okay, so mao ni siya latent heat for water, or marag theoretical siya nga latent heat at 100 degrees Celsius. So atong gingon ako ganiha nga HS minus HF, marag mao lagi to siya latent heat of vaporization. No.
Okay, ma'am. Thank you.
Okay. So i-try lang po ninyo ni-recall, no? Ang nadumduman ani nang nani siya sa term at try na kong tamaw. Ay, oo, naa siya. Naa siya diri ato i-open ha. Term 1. Ano to? Uy. Kare-kare. No, kani siya. So 100 degrees Celsius sakto na boiling water. Okay. Okay, so wala na other question. So let me check the attendance. Ay. Okay, please say present. Aheno.
Present Ahino, ma'am.
Apale. Apale. Okay, present. Baliwis. Baliwis. Beldoro.
Present, ma'am.
Biniga.
Present Biniga, ma'am.
Beru.
Present, ma'am.
Biloy.
Present, ma'am.
Bolotaulo.
Present, ma'am.
Botero.
Present, ma'am.
Boyonas. Canlas.
Present Canlas, ma'am.
Creencia. Cocharo.
Present, ma'am.
Felicita. Gusto mo